Hello, and welcome to this recorded e-learning on embedded system design with the Xilinx Embedded Developers Kit. My name is Frank Nelson. I am a Xilinx technical trainer and course developer. I'll be your instructor for this module. In this module, we will learn about the primary uses of the Embedded Developers Kit, commonly called EDK. We're going to spend some time discussing the contents and functionality of the toolkit, typical embedded system hardware, and commonly used debugging flows. After listening to this recording, you should listen to the other RELs on embedded design. These include the embedded design with MicroBlaze, that is, the Xilinx's soft processor core, and embedded design with the PowerPC 440, which is a hard core included with Xilinx's Virtex 5 FX FPGA family. These remaining modules complete the course offering. The information in these recorded e-learnings is essential to the success of our customers as they build their embedded design. However, due to their timing limitations, we still recommend that you attend the Embedded Systems Development course. Welcome to this REL on embedded design. If you're new to embedded design with Xilinx FPGAs, this module will help you start planning your design and start to understand the overall design flow that you're going to encounter when targeting an embedded design towards a Xilinx FPGA. We're also going to try to help you understand the differences between Xilinx's FPGA architectures and how that is essential for you to be able to select an appropriate FPGA device family so you can build an embedded system that is right for you. The Embedded Developers Kit software, or EDK, is designed to make building a custom embedded design easy. It also includes software compilation as well as debugging functionality, and we'll talk about that a little later. After completing this module, you'll be able to choose between a PowerPC 440 microprocessor and a MicroBlaze processor system. You'll also be able to explain the primary tool functionality included with the Embedded Developers Kit, or EDK, and explain the benefits of building an embedded design within an FPGA architecture. Our first topic will be to introduce our embedded product offerings, device families, and discuss typical embedded hardware design. Xilinx's embedded processor solutions include the MicroBlaze soft processor core and the PowerPC 440 hard processor core. While MicroBlaze is a soft implementation, which means that it is built with standard FPGA logic resources, including LUTs and registers, the benefit being that it can target any of Xilinx's FPGAs. Now, MicroBlaze is a 32-bit RISC processor that obtains modest performance up to 300 MHz in the newest FPGA architectures, but this will depend on the device family and the speed grade you choose. The PowerPC 440 is available from the Xilinx Virtex 5 FX family and is dedicated in the silicon. This means that it can obtain higher performance and have a top speed of over 450 MHz. Don't forget that the PowerPC 440 on our FPGAs is the same as the off-the-shelf version. There has been no optimizing or simplifying of its architecture. It's literally the same ASIC, just fused to the FPGA's interconnect. Now, both of these processors use the PLB v46 bus standard, but that's not very important because EDK includes IP that is optimized for this bus standard, so it almost doesn't really matter what bus standard you're working with. As I mentioned, MicroBlaze allows designers to target all of Xilinx's FPGAs. These include the low-cost Spartan device families as well as the high-speed Virtex families. Likewise, the PowerPC 440 can only be used to target the Virtex 5 FXT family. That is because it is the only family to have a processor dedicated in its silicon. Now, support for the PowerPC 405 can also be done if a designer wishes to target the Virtex 4 FX family. All of these processors are supported with EDK and include optimized peripherals that save customers from having to build them from scratch. Now note that Xilinx's newest family members, the Spartan 6 and Virtex 6 device families, currently only support MicroBlaze, since there is no dedicated processor included with their family members. A Xilinx embedded system can be nearly any computing system. It is typically single function so that it is small and efficient. This is beneficial to FPGA customers because they don't have to purchase an expensive off-the-shelf component that already has a large number of peripherals already added. The FPGA solution allows customers to add only the essential peripherals they need and build any custom peripherals they can't get from an off-the-shelf component. Typical embedded systems are tuned for low cost, minimal power consumption, relative speed, as well as minimal FPGA resource utilization. The software platform support from EDK includes a standalone system that uses C and includes a library of drivers optimized for the peripherals included with EDK. Your software system can also include a real-time operating system, commonly called an RTOS. An RTOS allows the embedded system to monitor the system and respond rapidly to a change in the system. RTOSs tend to have a large amount of software associated with them, so their use usually requires the designers to store their software in an off-chip memory component, such as an SDRAM. There are a few different RTOS vendors available to you. Check out the Embedded Design webpage to find an RTOS that is right for you and your processor, because of course they'll vary depending upon whether you're using the PowerPC 440 or MicroBlaze. As you may know, many customers like to store their software code inside of the FPGA's block RAM. The caveat to this, however, is that there is a limited number of block RAMs inside the FPGA, but this will depend on the device family and the density of device you choose to purchase. Typically, most customers choose to use an off-chip memory for their application if they need a large amount of software. To aid this, EDK includes a number of optimized off-chip memory controllers that support a variety of types of memory components. Spartan 6 even includes a dedicated programmable memory controller that allows you to target the most popular memory components in the industry.